case, let's do a gram to mole problem. Yeah. So you need to start with a balanced equation.
Hey, look, we have a balanced equation.
It's actually the same equation. So we're just trying to kind of make sure you understand it. So, guys, something very important that you ought to do is to write down these examples. As I've been checking some students' notes, they're not writing all the examples, and these examples are critical to help you understand this. So what are you going to do? Write the examples. If you don't, Mr. Samus will take your thumb. Oh, no, he won't.
No, I won't do that.
Okay, never mind. 4.53 grams is what I know of potassium chlorate, so I know that. Okay. How many moles of oxygen? Okay. Hey, it's kind of like the same problem.
Yeah, we're just going to have one additional.
But we're starting with a different unit.
Yeah.
So maybe we should look at the
mole map.
The mole map. Okay. So what have we got, Mr. Sanders?
We have grams of a substance.
So we're up here on the mole map.
Yep, and we're going to moles of another substance.
So I need to get from here to here.
Right. So to do that, we're going to have to go through moles of A.
So it's like a two-stepper there.
It is a two-stepper.
I would call it a three-stepper because you start with what you know. Right. So we have to use the molar mass and we have to use the mole ratio. Okay, so well, let's do that.
Okay.
So well, we start with what we know. It's a fraction over 1, right?
Yep.
So 4.53 grams of KClO3. Okay. And, well, we need to use the molar mass
We
first.
do.
So you'll say grams of KClO3 to 1 mole of KClO3. So we have grams of KClO3.
Yeah.
The number is, now Mr. Samms, I'm going to amaze you because I did
know
not
this off the top of your
use
head?
my calculator.
Come on.
I know this number off the top. It's 122.5.
It is.
122.5. Now, where did you get that, by the way? Make sure we understand that for our students' purposes.
Well, apparently out of thin air. No. I just added up the masses of potassium, chlorine, and 3 oxygens. So 39 plus 35.5 plus 3 times 16.
And we got that on the periodic table, guys.
We did.
So just for molar mass. So so the grams of potassium chlorate cancel.
Okay.
Now we've done the mole to mole ratio. Now what we need to do is we want to go
was
from
grams to mole.
grams to moles.
Now we need
to do mole to mole. That's what I meant to say. All right. And so now I've got moles of KClO3. So I'll put moles of KClO3. Notice I put the thing on the bottom first because that's what I want to cancel out. And I'm going to say moles of O2. And I get that number. Now, where do I find that number? I don't see that anywhere.
That comes from the balanced equation.
Balanced equation.
2 and 3.
2 to 3. Now, the 2 goes with the KClO3.
Yes, it does.
And the 3 goes with the oxygen. So, now this one, times on top and divide on the bottom. So, 4.53 times times 3, divided by 122.5, divided by 2 equals
0.0555.
And that will be moles of oxygen. All right. Now, we're not showing the calculator, guys. I think you guys are good enough for the calculator at this stage of the game. Hey, what if we went from
grams to grams?
So this problem, we're going to go from grams to grams. So let's figure out what we got. We got 8.26 grams of O2.
Wait. We're starting with a different thing this time. We're not starting with grams of KClO3?
Yeah. So
what? We can start with a product?
Yeah.
Guys, so you can start with anything. Doesn't matter.
Yeah, 8.26 grams of oxygen and asking for how many grams of potassium chlorate. So this is a gram to gram problem.
Yeah.
So now we should probably look at
go to the mole map.
Mole map, okay. So we're starting with grams of A, okay.
And we're going to grams
of B. So we need to go from here to here, but there's no
We
line.
can't go straight through. We have to go through the land of the moles.
So we use the molar mass,
Yes.
and we get moles. Then we go from moles to moles, and then we go from moles to grams.
Right.
Using
So
the
we
molar
use
mass twice.
Molar mass and
Why
then mole ratio.
should we use the molar mass twice? That just seems like silly.
Two different substances.
That's the key, guys. We have 2 different substances that have different molar masses, okay? Okay, so let's figure this out. Okay, we have 8.26 grams of oxygen. Now notice, by the way, guys, I'm really trying to write everything way over on the left side because I know this is going to be a very wide problem. And so just to kind of keep in mind, this is not like center your text kind of a thing. All right, so then I'm going to say, okay, I want to go from grams. So I'm going to use the first step was the molar mass.
Right, molar mass.
So I'm going to say grams of oxygen to moles of oxygen. 1 mole of oxygen is 32 grams. O is weighs 16, so 16 times 2. It's actually 50.999 or something like that. Okay.
Close enough.
So close enough to 16. Technically, we like to go to the 10th of a decimal, so it would be 32.0.
Yeah.
All right, so grams of oxygen cancel. So now I have moles oxygen. Now I need to get rid of moles oxygen. So I'm just, put moles of oxygen on the bottom.
Right, so this is the mole ratio step. To go from moles of one thing to moles of another thing, we use a mole ratio.
So then I'm going to say moles of potassium chlorate. Now I get this from the balanced
equation.
Chemical equation.
Yeah.
So this will be a 3, and this will be a 2. and the moles of oxygen cancel. I've got one more step because I asked
Yeah.
to find grams.
Because now we need to go from moles to grams. So we use the molar
We've
mass,
done that.
this time of KClO3.
Moles of KClO3 to be grams of KClO3.
And we do that using its molar mass. And Mr. Bergman, you memorized that, I believe?
Yeah, 122.5.
Okay. So I have limited brain space. I try not to memorize things like that.
All right, so Mr. Sams, if there's numbers on top,
Yep.
what do you do?
We multiply it.
In the bottom?
We divide.
So it'll be 8.26
Yep.
times 2 times 122.5 divided by 32 divided by 3 equals.
Equals 21.1.
So what this means, guys, is if you were to start with 8, or finish, you would produce 8.26 grams of oxygen. It would come from 21 grams or 21.1 grams of potassium chlorate.
Yeah.
You see, this is important. Why is this important, guys? Because scientists want to know how much they're going to make when they produce something. I mean, if you work at a factory where your job is to build particular chemicals, you need to be able to predict how much you're going to make from the ingredients that you have. I mean, really, bakers do this all the time.
I was going to say, I did that last night when I made cookies with my kids.
Yeah. So this method we use for chemicals, but really it can be applied at the bakery. How many cookies can you make based upon the fact that you've got 4 cups of flour or something like that? Yeah. All right.
All right, I think this is the last one.
Okay, this one's going to go to liters, so this is a little different. So we should probably go to the
Mole map.
mole map. Okay. Mr. Sims, where are we going from?
This one we're going from grams to liters.
So grams of this first
substance
chemical, and we go up to
liters of the second chemical.
And again, there's no line
Nope,
from here to
you must
here.
go through the line of the mole.
So we're going to use this fraction, and then we're going to use this fraction, and we're going to use that fraction.
Yep.
All right, so let's do that. So what we know? We know we have 12.2 grams of potassium chlorate. My question mark here is oxygen.
Liters.
In liters. So we're going to convert from here to here. So we're going to start with our 12.2 grams of KClO3 over 1. Then we're going to say grams of KClO3 to 1 mole. This is the molar mass. And, of course, let's just add them all up, and we know now by now that it's
122.5.
Mr. Sims, I think you've got it memorized.
I think I'm never going to have to do that again.
Yeah. So the grams of potassium chlorate cancel. Now we need to do the
Mole ratio.
mole ratio, land of the mole thing, right? So we're going to say moles of KClO3, 2 moles of oxygen, and the ratio was 2 here and 3 there.
Okay.
Moles of KClO3 cancels, and we just have a new fraction, but it's not really new.
No, we've used it before, unit 3.
Now I've got moles of oxygen here, so I'm going to put moles of oxygen down at the bottom.
We've got to go to liters of the gas.
And this is at STP.
STP, so we use 22.4.
That's that 22.4 number. Okay, numbers on top are multiplied, bottom divide, so 12.2 times 3 times 22.4 divided by 122.5 divided by 2 equals...
Equals 3.35 liters of O2.
Oxygen. So you can predict how many liters of oxygen you would produce at standard temperature and pressure. So to summarize, Mr. Sams, what do our students need to do if they're doing these problems?
You need to follow the rules that we gave you.
Rules?
Okay? Now, there are other ways to solve these, but for now, do it our way. Okay?
Yeah, because they can get more complex.
They can get more complex, so don't try to do it in your head. Always write your units with the chemical with it.
That's right.
Always, always, always. And then use that mole map. It'll be your guide. Figure out what you know and where you're headed, and just follow the lines.
And at some point, you may not need to have the mole map.
Right.
But
for now,
you
use
probably
it.
do.
Yeah.
Okay. Well, we will see you in class, or maybe we'll never see you because you're on the